Hello everyone, today we are going to solve the Irked from Hack the Box. Like every machine, we are starting with the Nmap port scan. Let's jump right into the terminal. And the port is so we use -p- to scan all 55,535 TCP ports. To speed this up, I'm throwing in -min -rate equals to 10,000, which forces Nmap to send at least 10,000 packets per second. It's aggressive, but it gets the job done in under 10 seconds. So we have 7 ports open. We see standard things like port 22 for SSH and 80 for HTTP. But then we have some interesting ports 6697, 8067, and 65534. Nmap is guessing what these are based on standard port assignments, labeling them as IRCS-U and INFI-async and unknown. We cannot rely on guesses. Now that we have our exact target list, we are going to run our second targeted Nmap scan to interrogate these specific ports. 22. This time we pass in exactly the port we found using the -p flag. We add -s capital letter C to run Nmap's default vulnerability and discovery scripts, and -s capital letter V to perform version detection. We want the services running on these ports to actually introduce themselves. So let's break down the results. First, port 2020 is running OpenSSH 6.7p1 on Debian. Standard remote access, but rarely our initial foothold unless we bind credentials. Next, port 80 is running Apache 2.4.10. Nmap tells us the site doesn't have a title, which usually means it's a default page or a very basic static site. We will definitely be hitting this with GoBuster later to look for hidden directories. Port 111 is RPC bind. Now for the interesting part. Remember, like these 6697, 8067, and 65534 are running a service called UnrealIRCd. So IRC, or Internet Relay Chat, is very old text-based chat system. Seeing it running on this separate port is massive red flag and immediately becomes our highest priority target for investigation alongside the web server. We have our map, we have a web server on port 80 and an old IRC daemon running on multiple ports. Let's pivot over to the browser and see what a party is hosting, and then we'll figure out exactly what version of UnrealIRCd we are dealing with. Clear. Since Nmap showed us port 80 is open, our immediate next step is to actually look at what the web server is hosting. I always prefer to do a quick manual visual inspection before firing off any automated directory scanners. So we can move into this website. Two. HTTP. So we are greeted by a massive irked smiley face. But take a look at the text at the very bottom. IRC is almost working. In a penetration test or a CTF, context is everything. This single sentence perfectly corresponds our Nmap scan. We found 3 strange high ports running UnrealIRCd, and the web administrator is actively telling us that they are messing around with an IRC server. It confirms we are looking in the right direction. A golden rule of web enumeration is to always check the page source. Developers love leaving hidden comments, old links, or framework version numbers in the HTML. We hit Ctrl U to see what's under the hood. So there are no hidden developer comments, no JavaScript frameworks we can exploit. But we can find that the image called irked.jpg just in case it becomes relevant later. So since our manual inspection of the web page didn't give us a direct way in, we need to find out the administrator is hiding any secret directories or files. To do this, we are going to use a tool called GoBuster to brute force the web server's routing. So GoBuster DIRU. It tells GoBuster we want to run a directory brute force against our target URL. And for our dictionary, set list and this discovery web content and common txt. So we are using the common.txt word list from setlist. It's a fantastic lightweight list that will quickly find standard administrative panels, backups, and default folders without taking hours to run. The next flag, -x, is crucial. We aren't just looking for folders, we are telling GoBuster to take every word in our list and append these specific file extensions to it. We are hunting for hidden PHP scripts, old HTML files, text notes, backups, .bat, and markdown files. Finally, we set our address to 20 and silence the error message and run. So during our scan, we have interesting tree hit. index.html, it must be just a smiley base page we already looked at. A 2000 status code means it loaded perfectly. The /server-status endpoint returns a 403 forbidden, which means the server acknowledges the file exists, but we don't have the permissions to view it. But look at /manual, it returns a 301 redirect, pointing us to a directory. So whenever you find a hidden directory, you have to investigate it. In the real world, in CTFs, administrators often leave default installation manuals exposed. Sometimes these manuals contain default hard-coded credentials, or they reveal the exact version number of a vulnerability plugin they installed. However, as the page loads, we can see this is just the default Apache HTTP server version 2.4 documentation. So I'll click some of the links for sure, but there are no custom notes and no exposed configuration files and no developer secrets left behind. It is completely standard. So since the web server isn't giving us an immediate shell, it is time to pivot our focus back to our Nmap scan and attack the UnrealIRCd service directly. So if we just search UnrealIRCd vulnerability, we can find interesting CVE here, so we can search further CVE and then so we may want to use this module for attack. So go to the tmux screen and ms console -q. We start Metasploit quietly using the -q flag to skip the startup banner. So we need to find our exploit. It should be used. We can just search this at first. Search. Then use 0. And show options. Set our host 10. set our port. We can use this 6697 and exploit. If we get excited and just type exploit right now, it fails. This is a very common beginner mistake. Metasploit knows how to break through the door, but we haven't told it what to do once it gets inside. We need to attach a payload, specifically a reverse shell, to connect back to our machine. Show payload. So set payload. So we are going to choose a standard reliable command shell. So cmd unix reverse. So set lhost 10 14 18 and set lport. We use set host and input our attacking machine's VPN IP address. So we use lport to designate which local port we want to listen on. So let's say show options and then exploit. Where am I? So we have our initial foothold on the Irked machine as the IRCD user. So before we move further, we can check more about this vulnerability on your IRCD exploit. Sorry, it should be 3.2. So there is good explanation here, so we can look this. The discovery and announcement of a backdoor in UnrealIRCd is embarrassing for the project. Certain real-life security vulnerability is not Linux specific, and this has happened to any software project. UnrealIRCd is, as its name implies, an internal relay chat server. It runs on most platforms and has added a number of features that some folks find useful in an internet relay chat server. It is not related to the Unreal first-person shooter game as some reported. It is simply a server that can be run to host IRC channels for a wide variety of purposes. From what the project can tell, around November 10th, 2009, the mirrors of the source distribution of version 3.2.8.1 of UnrealIRCd were replaced with a version that contained a backdoor. The backdoor could be used by an attacker to run any command on a system running the compromised server. Obviously run with the privilege of the user that executed the server. It took until June 12th for this swap to be noticed. So anyone who picked up a copy of the code in the 7-month period may be vulnerable. So the backdoor was disguised to look like a debug statement in the code. Debug 3 log eventually resolves to a call to system. Oh, we can call to system while debug mode 3 info is just string AB. Thus, commands sent to the server that start with AB will be handed over directly to system. Maybe you can use this idea. Commands sent to the server that start with AB will be handed off directly to the system. So we can make our we can exploit this manually using this information. So we can set up our netcat listener on port 4445 to catch our reverse shell. So at first we can use another teamwork session, and I like to set the 4445. And we can connect to the RC server and send our AB trigger. So NC NB10, and then the port will be 222 and 6697 AB UMI It says couldn't resolve your hostname error is showing. So instead, we will package our entire payload into an echo command and shove it down the network pipe the exact millisecond the connection opens. So it says ping timed out. So what you're going to do is echo. We are preparing a string of text to send and AB. This is our trigger. The AB hits the malicious C macro we just looked at. The semicolon is a Linux command separator. It tells the system, try to run a command called AB, and when that fails, immediately run the next command. And then this is our actual malicious payload. It's a standard bash reverse shell pointing right back to our listener on port 4445. And then finally, the pipe takes everything we just built and injects it directly into the IRC port. and 6697. I think I missed this. So looking at this prompt, it's pretty if you want to like control, like who am I, control C, it got broken. So we want to upgrade this to a full interactive TTY. Can run this command again. So step 1, we use Python to spawn a pseudo terminal, Python 3. Import, I missed import. So we are importing the PTY module and telling it to spawn a proper bin bash process. So Ctrl Z, this does not kill the shell. It pauses our netcat process and pushes it into the background, returning us to our local attacking machine's terminal. And stty raw tells our local parrot OS terminal to stop interpreting special keystrokes and instead pass them completely raw over the network to the victim machine. And then echo tells our local terminal to stop printing what we type, because the remote bash shell is already going to echo it back to us. So if we don't do this, every letter we type will show up twice. And then fg immediately brings our post naked listener back to the foreground. And enter a couple of times. And this command simply tells us the remote machine special, what kind of terminal emulator we are using. It ensures that terminal colors work and that commands like clear or nano knows exactly how to draw themselves on our screen. And clear, and now Ctrl C. Yes, we don't like go out to the terminal even if we run this. Now that we have a stable interactive shell, it's time for local enumeration. We are currently the IRCd user, which has very low privileges. Our goal is to find the path to root. While manual enumeration is a crucial skill, running an automated script like LinPEAS will save us hours of digging through system files. But first, we have to actually get the script onto the victim machine. So copy and paste for the to download the linpeas.sh directly from the peas-ng GitHub repository. And run the Python web server. and move to this temp folder. It is almost always worth writable, the temp folder, meaning even our low-privilege IRCD user can save files there. So wget 10.13. And make the script executable and run this command with saving the output. So LinPEAS has finished running, so we can use -r. It tells the terminal to render the raw ANSI color code. So by using -r, we keep all the vital color coding perfectly intact inside our text viewer. So make this a little bit bigger and let's linpeas.txt. So there's a section with users with console. So we understand that DJ Mardov may be the user for the next target, and then this user has a lot of groups, and there is something interesting like this, unknown SUID binary. We will investigate this later further. Capabilities. So searching root files in home directories, it says like DJ Mildov should be the one that we need to pivot before getting the root shell. And then let's get to so all relevant hidden files. So we can find some interesting backup file here. So it is owned by DJ Mardov and it is sitting in the documents folder. And third, it is explicitly named backup and hidden with a dot prefix. So given the permission, we found that IRCD user even has the access to check the file. So we can copy and end this. Cat and it says like super elite stack backup PW. So this is the exact moment where note taking pays off. The crucial clue here is the word stack. In cybersecurity, stack is shorthand for steganography, the art of hiding secret data inside an ordinary, non-secret, almost always an image or audio file. So we have a password up, up, down, down, and something like this. And then copy and paste. Maybe I can copy and paste like this. And let's think back to our initial enumeration base. Did you find any file shares with images? Then we can find where the image was. So we can navigate to this website. There looks to be an image here. We can use this image for the steganography technique, and we have our password, we have our target image now. So I can download this file using this is LinPEAS, so we can end wget and 222. So we download this file. So when you see this JPG file and a password, the industry standard tool is StackHide. It's important to understand how StackHide works under the hood. It doesn't just lazily glue a zip file to the end of an image. So instead, StackHide compresses the secret file, encrypts it using the password we just found, and then uses a complex graph theoretic algorithm to subtly alter the least significant piece of the image's actual color pixels. To a scanner or hex editor, it just looks like mathematical noise. You must have the exact password to reverse the math. Sometimes your local attacking box might not have StackHide installed or the package manager is acting up. Instead of burning time troubleshooting your own OS during an exam, always have a backup plan. So we are going to use an online StackHide extractor hosted by Boxentrick. So we can find this. We can just heist it online editor. We can just check like this website and select file, home, this, and password should be this. Extract message. We found this password, so we need to navigate to the SUID Mardop. If you use this password, I can do this again. Perfect. So who am I? And our final goal is to compromise the root account. Whenever I land on the Linux box, one of the very first things I check for is misconfigured SUID binaries. SUID stands for Set Owner User ID. If a file has this special permission bit set, it means that when a normal user runs the file, it executes with the privilege of the file's owner. If root owns the file, we get to run it as root. We can run the Python server again and transfer sh again. I think then chmod and txt. I'll do like this. So we can investigate the LinPEAS.djmardop.txt file, and to save time, we can check the SUID that we checked before. So we found that there is like unknown SUID binary thing. So we need to figure out which one is a standard package the script just missed. And when it comes to this Spice GTK, we can search Spice client kill leave USB ACL helper. This looks to be the widely used package. And we can check the user bin viewer user further. Bin viewer user package. User bin view user package. I think they don't look to be standard package. So and view user doesn't look to be standard Linux command either. So and this permission is we can also execute this as a owner user root. So we can try to run this command at this stage. User bin view user temp list users not listed. We can check this, grab list users. It doesn't exist, so user develops test user permissions. We can create this command with the malicious payload potentially. So echo bin bash. So we are going to use echo to write bin bash directly into a new file called temp list users. Then it will be run executed by the root user with the root user permission, and we can get the root shell potentially. This and run this command again. Permission denied, so stage mode temp is users again. Interesting. Forgot X, so again. Perfect, we can get the root shell and who am I? We are root, and we can now navigate to the root directory and get the flag. So Irked is a fantastic machine because it tests your ability to connect the dots. So we mapped an old IRC backdoor, bypassed a network timeout using standard input piping, found a hidden backup file, used Steganography to extract a password from an image on the web server, and finally leveraged a path injection vulnerability in a custom SUID script to get root. So thanks for watching, and see you next time.